So when you're writing a code for a program, you have, a bunch of, if statements, you have a bunch of loops, but trying to think of how to write a program that you have to, as you said, recognize patterns. The more complex the pattern, the larger the program has to be. And you need to look at every single input and calculate the size of the code that you would have to do just doing, the if statements, the while loops, all of that, all the variables, actually even just the number of variables you'd have to have.
3, 2, 1. Welcome to Love Machine.
Welcome to another episode of Nerding Out with That Nerdy Catholic. I'm Seth Payne. I'm here with my always co-nerd Cesar, and we are jumping in to our new series on AI. We've had a couple of episodes kind of introducing the topic and welcoming everyone's your input. I want to remind you then, if you go to thatnerdycatholic.com/AI, you will see a list of all the episodes that we've done on this series. There's also a form in there. If you have any thoughts, any questions, what are some important topics on AI that you would like to be addressed? What is something that you would like us to talk about on any aspect of artificial intelligence? We want to hear your thoughts. So there's a form on that page to let us know what you think, your questions, the things you would like us to cover. If you go to thatnerdycatholic.com/merch, you can get t-shirts and mugs, some of the cool things that we have to show the world that we are nerds and we love it. And if you head over to thatnerdycatholic.com/support, you can help support us financially. And we appreciate everything that you've done, everyone that's helped us out financially. And we also welcome your prayers and encouragement. And we want to be part of a greater community. It's not just us as these amazing experts, but we want to be part of a greater conversation. So we welcome any help or input that you have. So Cesar and I decided that AI it's been around for a while.
Yes.
But it's been in the news and people have been talking about it a lot in the past year or two. And there's a reason for that. AI, I remember, I think I mentioned this before, taking an AI class back in the 90s. But things have changed. And so we wanted to, in this episode, just take a really kind of a high-level overview, looking at what artificial intelligence is. And then in future episodes, we're going to be looking at a lot of the implications about what it is, what it isn't, how do we use it, how should we think about it. But today, Cesar, start us off looking at the overview. What is artificial intelligence?
Yes. So one of the things that we want to do starting this series is say, well, let's put first of all the facts and the definitions for what it is. No. So what are we going to do in this episode is go more on the things that cannot be disputed. No. How is it built? How was it built? What are the main concepts? What do you have to understand? A little bit of math. We are not going to dive into math, but we have to understand what is the math behind that and how does this evolve into what we know what is AI. No? Yeah. So it is important that Seth is correct. AI has been for decades up to this moment, but the main thing, when we think right now, when we talk about AI, is something that we can interact as it were a human being. No? So AI, we basically talk about large language model. But the concept of large language model was born from a revolutionary paper from Google's researchers. No? In 2017, it's a paper called "Attention is All You Need." No, that is really what started the AI revolution. No, and with ChatGPT, and GPT meaning generative pre-trained transformer. So that's what GPT stands for. No? AI took another level because not only the scientists, but common people just talking to the machine can start to receive answer, no? Can start to interact. No? So what is generative mean? Generative means that it's able to generate no, meaningful text given the context that it is given. No? So that's generative. Pre-train, it's also, everybody at this point should know that you pre-train the AI, but pre-train means that there's a possibility for you as a final user to further train more your AI on the specific of what you want. And the transformer is probably the part that we are going to dive into what a transformer is right now.
Yeah, and looking at the term pre-trained, when people talk about how much computing power is needed for AI, that's what the computing power is needed for.
Yes.
You know, one of the companies, looking at all the companies that have done really well in the AI sector, one of the companies that has done the best is NVIDIA.
Yeah.
Because NVIDIA makes they've made graphics cards for decades, but NVIDIA makes the chips that have it's the GPU, the graphical processing unit in the graphics cards, does a much better job performance-wise for training AI than your regular, the CPU in your computer.
That's correct.
So when people talk about, how many servers a company has and how many computers they're adding every month to their data centers, that's what this is for, the pre-training. And the pre-training, we'll look at this more as we go along, but the pre-training uses a lot more computing power than actually using the AI.
That's correct. Yes, that's totally correct. So let's dive into the transformer part, no? The transformer refers just of a kind of network, no? A machine learning model, which is at the core of the invention of the AI. But before we go into the transformer, we want to start with giving 4 basic concepts, no? The artificial neuron, what is an artificial neural network, what is machine learning, and what is a large language model, no?
Yeah. Well, and just another term as we start. I've always thought it was interesting that term is used, a neuron, because what are we trying to do? Artificial intelligence. We're trying to model. I mean, this was started. The field of artificial intelligence was started to try to model the human brain.
Yeah.
And so we know that the brain is a network of neurons. And so that was the initial idea behind how do we create something that can, quote, learn.
Yes.
As we try and, as best we can, model it on the structure of our brain.
Yes, that's correct. And because of that, but when we see this, what is behind AI? It's a mathematical model that we need to understand. We are not going to dive into the math, but we need to understand for what it is. No.
Yeah.
So let's start with artificial neuron. No. The key word here is artificial. No. Neuron is a biological being. There's a lot of the neurons that we currently don't know, but as far as we know, how can we emulate the work of a neuron? It is the artificial construct of the mathematical construct that is behind. No, so mathematically we talk about a neuron being basically a function, no? Which inputs are weighted different. They are all sum up. They pass through a nonlinear function and they add a base to that. No? That is basically a neuron. No? At the end, the result of this function that this artificial neuron is performing is a number between 0 and 1. No? Takes a lot of inputs, weight it up, summed it all, then add a threshold, then add a non-linear function, and the result is a number between 0 and 1. That is basically.
Yeah. When you look at a neural network, as Cesar said, you have an input layer, any number of inputs. Then you have any number of layers. Another term for each neuron is a node. So you have a number of nodes, then you have another layer with any number of nodes, then you have a final layer with any number of nodes, and that's the output.
Yes.
And so if you think about this, you have the first layer, it's just numbers. As I said, each number is between 0 and 1. Then you have every single layer after that, all it is an equation. It takes every single node in the layer after that is connected to every single node in the layer before that. And we're, if you think about it, even just a simple example we're going to look at in a second has a large number then of nodes, of connections between nodes.
Yes. So what Seth have just described is the artificial neural network, no?
Yeah.
So as a gathering of all those artificial neurons constitute an artificial neural network, and this has many use, no? There are several kinds of artificial neural network, no? The one that Seth described is the feed-forward artificial neural network, no? There's another one.
Which so basically means that you have inputs, it goes straight through,
and you have an output.
Yeah.
Yes.
Yeah.
There's another one that is the recursive neural network that has a feedback loop, no? The convolutional neural network, which those other we are not going to touch based on this because the feed forward is the easiest one to understand. But it's enough to say that if you see it simplistically, so if we think about each node as a function, as a mathematical function, a neural network is a mathematical matrix with a lot of layers that has nonlinear functions to have an end result, no? And each layer modifies the several inputs through that process. No?
Yeah, and the example that we're going to be looking at, there's a great YouTube channel out there, 3 Blue, 1 Brown.
Yes.
And the channel itself focuses on math, different questions on math. And so they dive deeply into the math behind neural networks, artificial intelligence, the large language model. But when I started watching those videos and learning more about this, I was brought back to college because I think it might have been the math class that I struggled the most in was linear algebra.
Yeah.
And linear algebra pretty much is using matrices, having a matrix, of large or small of values and doing math between the matrices.
Yeah.
And that's all that this is. The math behind it is calculating matrices.
Yes, exactly. No? In the next picture here, you will see how is represented the neural network. No? In this case, a neural network. No? The H basically is the output of the current layer. No? So you see that there's a feed forward. The previous A is the layer that we are. Then we add all the weights. No? We add the base, which is the threshold, and then we apply the sigma, which is the nonlinear function, and you have the result for the next layer. No? Please note that these are not numbers. As Seth correctly said, these are matrices. No? To be honest, the word they use is tensor because they have multiple dimensions. No? So I'm not going to talk about how many billions of dimensions it has currently ChatGPT 5, but these are not numbers. No, they are represented like that, but each one of the A's and B's are tensors. So that's tensor math, tensor multiplication. And as it says, is linear algebra with the caveat that there's a non-linear component after each layer that is applied. No,
I know that there a lot of these words even now can't make my head feel like it's spinning. The main point that we're saying here is that it's math.
Yes,
it's math, and as far as we know, well, we don't know. We have no idea, as we said, how our brains actually work. We know that there is a structure, but as far as what exactly happens between neurons, we don't know. But when you're looking at a way to translate this to a computer, what do computers do? At the base level, a computer is just a very large, very complicated calculator.
Yes.
Right. And so, however we think our brains work, the only way to translate this in any way, the only way to simulate our brain is to figure out how to do it with math.
Yeah. I'm so grateful that we already passed the math, our math series. So if you have any questions about math, please check out our math series.
Yeah,
it's really good
series
about that.
on the history of math, looking at that, how
that
math
evolved.
developed and evolved over the last 2,500 years.
There's one more thing that I would like to add before we move forward with the example, which is I think it's the next one. Every neural network has a great advantage, which is recognizing patterns, no? And this is not only for the large language model. This was all the way back when we started, I think in the 70s, when we started the artificial neural network revolution. No? It was brought to our attention because the neural networks were really great to recognize patterns. No? And in a way that, instead of having a programmer try to identify instruction by instruction, try to identify a machine that this is how you recognize this is a cube, this is a square, this is whatever pattern it is. The scientists discover, the mathematicians actually discover that this neural network structure was really good at recognizing patterns. So just hold that thought as we go through the example.
Yeah, and so another way to say that is imagine. So when you're writing a code for a program, you have a bunch of if statements, you have a bunch of loops, but trying to think of how to write a program that you have to, as you said, recognize patterns. The more complex the pattern, the larger the program has to be, and you need to look at every single input and calculate the size of the code that you would have to do just doing the if statements, the while loops, all of that, all the variables, actually even just the number of variables you'd have to have. And it's hard enough writing a program, even thinking about that Nerdy Catholic website, or the other websites I've worked on. It uses WordPress. The base language for that is PHP, and so there have been a number of pages where I've tried to customize. You use a few variables coming in. Having a page or any program where you have 10 variables to keep track of that is tough. You add another 10, that gets kind of confusing trying to keep track of all those 20 variables. But we're looking at even a simple example that we're looking at here has hundreds of inputs.
Yep.
I couldn't imagine
trying
to keep track of hundreds of variables.
Yep.
And so the idea of a neural network that you put in, you just say, here are the inputs, and as we look at what it means to train AI, we'll see that it takes the responsibility of keeping track of all those out of the programmer's hands.
Yes, that's correct. No. So right now we are going to see an example that is from three blue, one brown, no? Which is the number recognition. No, a machine that is capable to recognize handwritten numbers from 0 to 9. No. And how they do that is they lay out a number in a 28 by 28 pixel grid, and that each pixel it's a piece of information, no? And depending from, let's say 0 is white and 1 is black, and there's from 0 to 1, there's the shade of the different grays that can be. How do we build a machine that written a number in that grid can recognize if it's a number between 0, 1, 2, 3, 4, 5, 6, 7, 8, or to 9? No? So that is a great example, no? Seth, do you want to explain the next one?
Yeah, as Cesar said, you have a 28 by 28 pixel image. Every single one of those pixels is a number between 0 and 1 based on how dark or how light it is. So you have this neural network where the input is 784 nodes, one node for each pixel in the image. Then the next column is 16 nodes. The next column is 16 more nodes, and then the final column is 10 nodes representing 0 through 9. In the ideal state, where it is getting it correct every single time, you're going to have in the second column 16 equations, the third column 16 equations, and in the last column 10 equations. All of those equations balanced and tweaked so that for whatever number however you write your digit, the values in the first column are going to be put in. It's going to go through all the calculations, and it's going to end up the node in the last column that corresponds to that actual number is going to have the highest value.
Yes, that's correct. No, so that's a very good example. If you want to deep dive on this, just go to 3 blue, 1 brown. But we are not going to dive in it. But what are we going to say is, this is as simple as it can get. No, very, very simple. No, and just for this simple neural network, we have more than 13,000 parameters that somebody has to adjust. No?
So one of the things that is important thinking about this, there are 2 parts of the equation, of each equation in every single node that I want to talk about. So you have weights and you have biases. So you have an equation that looks at the value of the node before it, of all the nodes before it. But for each node before it, it gives it a weight for each individual node, and it gives a bias that is adjusted for all of the nodes. And that's it. It's an equation with those 2 parts in it.
Yes.
And then we'll look at what it means to train it, because one of the interesting things about this example, watching the videos, is where do you start? How do you start? If you just put in just simple equations, you're going to put in all the values for each pixel, for every single number it's going to go through, and you're just going to get random. There's no way, you might get, statistically, some of them are going to be correct. But most of them are going to be wrong, because there's no way to know what the weights and what the biases need to be to have the inputs to get the right answer.
That's correct. So that's why we have the next chapter, which is machine learning. Instead of somebody like Seth or me trying to adjust more than 13,000 parameters, what is the correct number for those, and try to figure it out, we let the machine know by a function how to adjust those parameters. No?
If you think about how some of my professors, and actually my father-in-law has told me stories about writing programs in the early computers using punch cards. Would have a stack of punch cards, and so you would write your program, print it out on the punch cards, put it in the queue to have it be compiled. You come back 24 hours later, you get your punch cards, you see errors. Then you have to go fix those errors, do all the 24 hours for a compilation cycle. And so I always thought, it's like, oh my goodness, I can't believe I couldn't imagine what it would have been like to have to do that. I would much rather have to write programs on a punch card, put it into the machine and wait 24 hours, than have to try and tweak 13,000 equations and all these nodes to try and figure that out.
That's true. I'm going to give a definition from Google Gemini about what is machine learning here. No, machine learning is a specific application of AI that focuses on enabling systems to learn and improve from data without being specifically programmed from every task. Instead of providing a set of rigid instructions, machine learning algorithms are trained on a large amount of data. Through this training, they identify patterns, build models, and use these models to make predictions or decisions on new unseen data. No? So in this case, we have data that we are going to use for training, and data that we are going to use for corroborate that the machine has been trained correctly. No?
Yeah. Just a quick aside. One of the episodes that we're going to do in this series, looking at some of the language that's used in AI and what are the implications of how we think about this, of AI learning, of AI being trained, because I think it's the language that we use has huge implications on how most people view artificial intelligence.
Yes, exactly. So and this is correct, because when we think about machine learning, we think like something like Skynet or all the sci-fi movies that we have seen when we were kids. And I would say it's worse than that. It's a lot of really complicated math.
Yes.
No? Because if there's a cyborg, you can always shoot that cyborg. Right? the complicated math, you have to figure it out.
Yeah.
No?
Yeah.
But if we want to describe this process, I'm going to just lay out this process. No? The first part of this process is data collection and pre-processing. No? So you have to have a large set of data. No?
Yeah. I can't remember the number. The 3 blue 1 brown, the example that they use that we're going through, you can actually get the code from them, and there's a website that they get their data from that has thousands and thousands, it might even be millions, I can't remember, of examples of handwritten numbers, and a file that tells you this handwritten number is a 3. This is a 2. So you have this data set that you have to train on, that you already know what it is.
Yes. So that is the most important thing. You have to get large amount of data, and then separate that data in two. No, the one that you are going to use to train, and the one that you are going to use to verify that the machine has learning correctly. No, then the second part is the model selection. No, you have to select the correct model. And choose all the input parameters which you want to minimize. No, in this case, there's a cost function. So right now we discover that we have 13,000 parameters that we want to discover. So we have to create a second neural network whose input are those 13,000 parameters. Sorry, and the output is just a cost function, no? And the idea here is to develop, and this I'm going to dive a little bit just to get into that. What is the minimum number of the cost function that can leave that to discover what are those 13,000 parameters, no? And how we do that with gradients and lot of complicated math to discover how is that, and assess state, because we need to have a huge amount of processing power. That means that the GPUs from the big data center are really used to, no? So that is the model selection. No, the training process is the part that we grab that model, feed into this let's say neural network, in this case with this 13,000 input, that will just have an output.
Mm-hmm.
And the idea is to find what are these values of these 13,000 input that give us a minimum of an output. And then when we find that, that is the correct number for those 13,000 inputs. No,
Mm-hmm.
Not going to go into the math.
Yeah,
You can see 3 blue, 1 brown if you want to dive into that.
I think the most important thing to think about then, as far as the training process, is you have, looking at the 784 inputs, the nodes after that, you have the weights and the biases.
Mm-hmm.
So you start off with, you put in, one group of the data set,
Mm-hmm.
maybe 100 or 1,000
Mm-hmm.
of those examples. You feed them through and you get an output.
Mm-hmm.
Well, you know what the output is supposed to be.
Mm-hmm.
And so you can look at the values of, let's say, in the 2
Yes.
node is a really high value, but it's a 7. And the 7 is a very low. And you see the values of all of them.
Yes.
So you can take that information.
Yeah.
Well, you can't. The machine will. They will take that information and say, I know what it's supposed to be. I see the values. And so I'm going to go back
Yes.
and tweak the weights and the my mind is blank.
Weight and biases.
Weights and biases of all of the nodes before that
Yeah.
to try and get not the right answer, but to get closer to the right answer.
Yes. And that's correct. The cost function at the end is the difference between what it should be and what the machine
Yeah.
So minimizing that difference is getting the machine learning to learn. So
Well,
you see,
and I think the important thing to think of then is the way that the program goes back and tweaks those values.
yes.
As I said, is trying to get closer, because we're not. I mean, if we were trying to train this model so it only recognized 7s,
Yeah.
that might be easier.
Yeah.
But we're trying to recognize all numbers.
Yes.
So, and that's going to happen hundreds or thousands of times.
Yes.
That you run a data set, check the values, see what it's supposed to be, see what you're getting, go back and tweak these biases and weights.
Exactly.
And then
repeat
and then
again
repeat
the
it
process.
again.
And repeat the process. And you see why it's so, why you need computer with so many GPUs processors. No? Because that has to be again and again and again up to find the minimum value. No? And you will say, why then some machines have different values than other? It's because in a math complex, you can have a minimum in a valley, but there are also various minimum functions depending on how you are approaching to be. So that is why no machine learning is equal one to another.
Yeah. You think about an image of even just a 2-dimensional graph. You have a curve.
Yes.
And you're going to have a number of places where you go down,
Yes.
and you have a local minimum, but you might have a total minimum down here. And the way to visualize how this program is working is you're trying to find that minimum.
Exactly.
And this is, but trying to do it with this, how many dimensions.
Yes. This is 13,000 dimensions instead of just 2-dimensional. One thing more is after that process, and it may take a lot of computer power and time to find those values, you got the evaluation test. You put the new unseen data to the machine just to verify that you have the correct thing, and then you deploy the machine.
So looking at this, then the way that you train these models, looking at the way that they learn. So there are 3 different ways that we have here, looking at the way that these artificial neural networks are, that they learn. So you have supervised learning. So what is supervised learning?
So supervised learning is a machine that, somebody external it's also looking and comparing the data. I try to guide the machine on what it should do. No.
Yeah.
Do. Yes.
So you have supervised learning where you have some programmer who is watching the process and is helping, maybe not tweaking all the values, but making sure, is this going the right direction?
Exactly.
Then I think the more common one now is this unsupervised learning.
Yeah.
So the machine is running the data set. It's looking at the values and the output, and it's saying, okay, this is what I know it should be, and this is what it is. So the machine then has a number of different algorithms that it uses to go back, tweak the weights and the biases, and running. So you look at. So you think about, even just for this simple example of the number recognition, and 700. We think 13,000 inputs, and these nodes and all that is huge. Just I'm trying to imagine this with millions. Even thinking about so this is looking at an image 28 by 28 pixels. What about image recognition for images that are
4K,
4K images, even
or videos,
1920 by 1080. How many pixels are in each frame of a 1080p video?
Yeah.
So you have to have, as we've said many times, so much computing power, because you have to go through thousands, millions of iterations of training to be able to say, here's the inputs, here's what we're expecting at the output.
Yep.
So I couldn't imagine, if you had to do supervised training with a model like that. So you have to create a system that the machine itself can run through all these, examples, and then be able to go back and tweak the values itself. And then what about reinforcement learning?
In the reinforcement learning, which is actually what we did with large language models, it involves an agent, which is a program that instead of a person, it's a program that learns and interacting with the environment, no? And it has some rewards and penalties, which is the agent, which is a program that supervises the software, which is a program, again, going back to somebody that, but with trial and error, they want to have the machine trying to get as fast as it can to the final results, but having an agent that says you are in the right path or you are in the wrong path. No, and this agent is not a person; it's a system, a software system that is helping the machine to track that.
And the agent itself, as the system is trained, you don't just have one agent. You have many agents, and the agents themselves can be tweaked. So it's almost like you have now a two-layer artificial intelligence. You have the artificial intelligence system that eventually is going to be, when you go to ChatGPT and you type something in, as you're typing, it's using that main artificial neural network. Right. But then for the training part, you have these agents, but they're also tweaking their code to better train the system.
And that is true. And this is often used in robotics, in gaming, and in self-driving cars. So if you ask how Tesla can do that, well, this is the way they do it. No, this is the way they do it.
Well, so that's. I know we've glossed over a lot of details. As we said, if you're really interested in how neural networks work, and especially if you're interested in the math behind it, we're going to put a link to the playlist for the 3 Blue, 1 Brown series in the description. We'll probably even put it up here in our, if we can. I can't remember if we can in the video, but we're going to put a link into the description for this series. It's really helpful to get a kind of an overview of how neural networks work.
Yes.
Yeah.
Yes.
Any closing thoughts that you have before we wrap up?
No, I mean, let's. We really continue to invite you with explore with us this artificial neural network. Next episode we are going to do the large language model, no, and we're going to do that in a different format, you know. As you know, I'm moving to another location, and we are going to continue.
Yeah. So the next video you see, we're going to be split screen.
Yeah.
When we're talking to each other, because we're going to be doing it remotely, but we're going to continue this series. So just a reminder, if you go to thatnerdycatholic.com/AI, we're going to have the playlist of all the videos that we've done so far on that page. But there's also a form on that page. If you have any questions, you can leave them in the comments on this video. But if you have any thoughts of things you would like us to cover, there's a form on thatnerdycatholic.com/AI. If you know anyone that is an expert in this field and you think that they would be a great person to have a conversation with, let us know. And we would love to have them on a future episode to talk with, because as we said, we're not experts in this field.
No,
we've enjoyed everything that we've learned about it, and in future episodes we're going to be looking at a lot of the implications of using artificial intelligence, both ethically, practically, as we said, looking at the language behind it.
Yes.
So if you have any thoughts, any topics you would like us to cover, let us know on that form on thatnerdycatholic.com/AI. But we want to thank you for joining us. If you go over to thatnerdycatholic.com/merch, you can get T-shirts and some mugs, some of the cool things. We have other kind of fun, nerdy designs over there. If you head over to thatnerdycatholic.com/support, you can help support us financially. That's going to help, especially since we're going to be remote, help with paying for the Zoom connections and the equipment that we need to do remote recording. And any help is really appreciated. We want to thank you again for joining us, and just invite you to come back next time as we continue to dive into artificial intelligence and what it means. All right, thanks. God bless.
Thank you. Bye-bye.
System shut down.